All right, welcome back to Tipping Points, everyone. I'm Miles, and tonight we're diving into a topic that's, well, pretty cool, literally. We're talking about the Arctic and how it's warming up faster than my coffee on a Monday morning. And to help us navigate these icy waters, we have a brilliant mind with us, Dr. Julien Dubois, a leading expert in polar climate science. Julien, thanks for braving the studio lights.
Miles, it's a pleasure to be here. And honestly, after studying ice for so long, these studio lights are practically a heat wave. Glad to be somewhere warm for a change, even if we're talking about things getting too warm.
Exactly. That's the paradox, isn't it? We're calling this segment Decoding the Arctic's Icy Future because the numbers are pretty stark. We hear the Arctic is warming 4 times faster than the rest of the globe. What's really going on up there, scientifically speaking?
It's a complex system, but at its core, we're seeing what scientists call the ice albedo feedback loop in action. It's a critical piece of the puzzle when we talk about the science of Arctic ice melt. So, the ice albedo feedback loop, right? Imagine the Arctic as a giant mirror. When it's covered in bright white ice, it reflects about 80% of the sun's energy back into space.
Like a super efficient natural sunscreen for the planet. I like that.
Exactly, but as that ice melts, it exposes the dark ocean beneath. And what does dark absorb?
Heat, like my car dashboard in August.
Precisely, Malik. The dark ocean absorbs up to 90% of the sunlight, warming the water, which then melts even more ice. It's a vicious cycle, a self-reinforcing loop.
So less ice means warmer water, which means even less ice. It's like the Arctic is eating itself. That's not great.
It's a significant contributor to what we call Arctic amplification. The region is warming 4 times faster than the global average, and this feedback loop is a huge reason why.
4 times faster. So if the rest of us are getting a tan, the Arctic is getting a sunburn.
A very accurate, if slightly terrifying analogy, Malik. Julien, how much of an impact are we talking about here? Is this just a small part of the climate puzzle?
Oh, it's massive. This ice albedo feedback has been responsible for a significant portion of radiative forcing, comparable to about a quarter of all CO2 emissions from 1979 to 2011.
A quarter of CO2 emissions? That's like saying a single snowball rolling down a hill is causing a significant chunk of the avalanche. That's a huge number.
So all those times I left the freezer door open, I was basically contributing to this? My bad, Arctic. My bad.
Well, Malik, maybe not your freezer specifically, but the principle is there. And this warming isn't just staying in the Arctic. It's messing with our weather patterns down here.
Ah, the jet stream. I've heard about this. So the Arctic's melting ice is giving us weirder weather?
Potentially, yes. Arctic amplification can affect the jet stream, making it wavier and slower. That can lead to more persistent and extreme weather events in the mid-latitudes, like longer heat waves or colder snaps.
So my unpredictable hair on a humid day? That's the jet stream's fault. Got it.
Blame the Arctic, Malik. Always blame the Arctic. But seriously, Julien, you mentioned the Barents Sea as a separate tipping point. What's special about that area?
The Barents Sea is actually the fastest warming part of the Arctic. It's like the hotspot of the hotspot. And studies suggest that reduced sea ice there is linked to colder Eurasian winters and altered precipitation patterns in Asia.
So it's not just a local issue, it's a global domino effect. And speaking of dominoes, the IPCC predicts an ice-free Arctic in some Septembers before 2050. Some models even say 2035. How do we make sense of those timelines?
It's tricky because of natural variability and model uncertainties. Some models are more aggressive, others less so. But the trend is undeniable. Arctic sea ice has been declining in both area and volume since 1979 at a rate of 4.7% per decade.
So it's like trying to predict when your phone battery will die, but with way higher stakes.
Exactly. And Julian, when we say ice-free Arctic, are we talking about just summer, or could we be looking at something even more severe?
That's a crucial distinction, Miles. Most predictions are for an ice-free summer, meaning less than 1 million square kilometers of ice. But the potential for an ice-free winter is a much more severe scenario.
An ice-free winter? That sounds like something out of a disaster movie. What would that even mean?
It would represent an irreversible tipping point with significant global climate implications. It would fundamentally alter marine ecosystems, impact polar bears hunting, and accelerate warming even further.
So no more polar bears delivering Coca-Cola? That's where I draw the line.
I think we'd have bigger problems than beverage mascots, Malik, but it really puts into perspective the scale of what's happening.
Absolutely. It's a stark reminder of the interconnectedness of our planet.
Julian, thank you so much for joining us and for shedding light on such a critical topic. We'll all be thinking about those polar bears and their Coca-Cola deliveries now.
It was truly my pleasure, Miles, and let's hope those polar bears find new jobs, or better yet, keep their old ones.
I'm just glad I finally have an excuse for my bad hair days. Thanks, Arctic.
Indeed. On that note, that's all the time we have for Tipping Points tonight. A huge thank you to Dr. Julian Dubois and to Malik for joining me. We'll see you next time.